Hello everyone, my name is Ankit Nanwal and today we will be doing some numerical based on the moment. So first numerical says that we need to find the moment. Okay, so we need to find the moment at x point. Okay, so for that the span of this beam is given 100 mm and then it is inclined 200 mm, which is inclined at 45 degree. Okay, so first of all, the force that is inclined, you need to calculate the what you need to calculation of moment is the product of force and perpendicular distance. So okay, so force you have, that is 4 kilonewton. Okay, so suppose this is the point x. Okay, here beam is like this and force is acting like this, so it will push the beam downwards. Okay, so this will be moving downwards, so therefore what will be the moment at x? Moment at x point will be 4 into perpendicular distance, which is the perpendicular distance from here to here. The distance is from here to here. Okay, when the distance is from here to here, we have only this distance. Okay, that is 100 mm, and for calculation of this perpendicular distance we have the angle 45 degree. For that you can calculate that cos 45 is equal to base upon hypotenuse. Hypotenuse is 200 mm and base you need to calculate. For that, base will be 1 by root 2 into hypotenuse is 200 mm. Okay, this is the base value and the base value will be coming out to be as 141.44 mm. Okay, you can check with calculator. It may be there may be a calculation mistake or what, but you can check by yourself. Okay, but the process is same, that the moment is force into perpendicular distance. As we are going towards the x direction, for that the force is here, the force is acting here, so force will try to rotate the beam like this. So moment is force into perpendicular distance, and perpendicular distance 100 mm we know, and this distance we can calculate through trigonometry function, that is cos theta is equal to base upon hypotenuse, and from here we get the value of base. Now the total distance will be, now for calculation of perpendicular distance, the total distance is, that is 100 is here plus 144.44. From here we will get to 41.44 mm. Okay, and the moment at x will be force into perpendicular. 4 kilonewton force or 4 newton force has been given, so 4 into the total distance, that is 241.44 mm. That is in mm, this is in newton. Okay, so moment value will be this into this, that will be how much? Newton mm. So you can calculate in newtons mm or newton meter. Okay, so you will get the value as 965.68 newton mm and 0.965 newton meter. Okay, so this is the first numerical. Now we come to second numerical. The second numerical says that you need to calculate the moment at this point, x point. So now this is the force that is given, that is 4 kilonewton. Now when this beam is like this and this is like this, and now this force that has been given here is acting inclined, that is 45 degree. When any force is acting inclined, so what will be the first step? I have told you, when any force is inclined, for that you need to first resolve the component. So for resolving the component, there will be one component in this way, one component in this way, one in x direction, one in y direction. Okay, so this angle is 45 degree, this angle will be 45 degree. So as this is 4 newton, this is 4 newton. When 4 newton force is acting like this, so the component which is having angle with that will be force f cos theta component, and this will be f sin theta component. Okay, now you can put the value. F is 4 newton, cos theta will be cos 45, and here f will be 4 newton, sin theta will be sin 45. When you will put the value, you will get the value that, now when we are talking about x distance, okay, now this is very important. You need to see that this is the x point. Okay, now when we are going towards this point, you can see the force one is above this line and one is acting perpendicular to them. One is horizontal but it is above the line. Okay, so you can see the both forces component will be taking part in producing a moment. How? This will be taking part, this one. Okay, let me change the color here. This force which will be acting downward will be taking force into perpendicular distance, and this distance is 100 mm. You can calculate this distance as we have calculated in previous, that cos 45 will be based upon hypotenuse. So this is 200 mm. Okay, as this is hypotenuse is known, you can calculate base. Okay, so this component will be force into perpendicular distance. Okay, now you can see this force component that is above this line of action. So this point is below. When suppose for example, if this force will be acting here at same line of action. Okay, suppose this was the line and this force was acting here, and we went to calculate the moment at x. So there will be no effect of this force in producing a moment. Why? Because the force will be there but perpendicular distance for this point will be 0, because line of this force is acting here. There is no perpendicular distance, because moment will be produced by the force into product of force into perpendicular distance, but there is no perpendicular distance in this case. Okay, but in this case this force is away from this line of action and this is having a perpendicular distance in reference to this point. As this is having perpendicular distance with reference to this point, so this will be producing a moment this way, as the point is downward, so it will be producing anti-clockwise movement and this will be producing clockwise movement. So the moment at x point will be the summation of the moments. Okay, so moment at x will be, as this is clockwise and this is anti-clockwise, so it is up to you that you are taking clockwise positive or anti-clockwise positive. Here I am taking clockwise positive and anti-clockwise will be negative. Okay, so what will be the components? So first of all you can calculate the clockwise moment. Clockwise will be f sin theta. F sin theta is sin 45 degree. Okay, now we have the component and the distance will be this distance plus this distance. So this distance in previous we have calculated it as 141, because the angle is same and this distance is also same, 200. So the what will be the base will be 141.44 mm. Okay, so now the base is this one. So as we know the force into perpendicular distance will be this distance plus this distance, so it will be 241.44 total distance. Okay, now this is clockwise and I have taken it as positive. Now other is negative because it is anti-clockwise, and anti-clockwise component will be f is for cos theta. Cos theta is cos 45 and the perpendicular distance for this point will be this distance. This distance you can calculate it as this distance. I am talking about the perpendicular distance. You can calculate by using sin 45 equal to perpendicular upon hypotenuse. So hypotenuse, you know that hypotenuse is having a value of 200 mm. Okay, 200 into sin 45 equal to perpendicular. So perpendicular you can calculate the value. The value of perpendicular will be same, as sin 45 and cos 45 is same, so the value of this will be same, that is 141.44. okay, and you can calculate by solving this you will get the value of the moment at x point. If it is coming out to be positive, suppose this is coming out to be 282.8, okay, that is Newton mm. Okay, if this is coming out to be positive, that means the resultant moment will be in clockwise direction. Okay, so you can write down here clockwise direction. Okay, and if it is coming out to be negative, that means the resultant moment will be in anti-clockwise direction. Okay, so this is how you need to solve the numericals. Okay, thank you.